Right. So we left off on the addresses that we have, the data link, the layer 2 addresses, and the layer 3 addresses, the IP addresses, the other ones being the MAC address. Now, we want to demonstrate what happens if I'm communicating on the same IP network. When I talk of the same IP network, this is a perfect example of same IP network. So my pieces are up in a same IP network here, making use of every interface on a router represents a network. So this is the same IP network. Look at the information which is being sent, the header, the data link, the network layer. Look at what the source and the destination MAC and IP addresses are. So to send the information from PC1, so this is the source. That's why we have AA here. Information in the data link header. This is the destination. Since we are on the same network, that is also the destination here. For the IP, this is the IP for the source. This is the IP for the source. Then we have, this is the IP for the destination. This is the IP for the destination. So if I'm sending information on the same IP network, it's not complicated. The source MAC is the source MAC. The destination MAC is the recipient of the information. The source IP is the originator, the origin of the message. The destination IP is the recipient. No complications. It becomes a bit complicated when we have devices on a remote network. Right. Now, instead of having to send to this device on the same network, we want to send information to a server, which is not on the same network. So this is network Irpayega. This is another network Irpayega. It's not the same network. So what will our headers look like then? What will our headers look like then? All right, just a minute. Okay, so we just came off the explaining how communication works, how addressing works when we are on the same network, same IP network. No complications, same MAC address for the source and the destination MAC addresses are for the origin of the message and the recipient. Same with the IP addresses. But when we are sending on a remote network, there is a difference. This, okay, all right, voila. This is the source. The MAC address is AAA. The source, the MAC address is AAA, no problem. This is the destination. The MAC address is ABCD, but look here. Our destination is not ABCD. Why? The reason why is because MAC addresses, they're only functional in the local area network. So what is the IP address given here? The IP address, if I want to communicate remotely, the IP address which becomes the destination, the MAC address, excuse me, the MAC address which becomes the destination MAC address, if I want to communicate remotely, it will be the MAC address of the default gateway. In this case, the default gateway is right here, and it has a MAC address of 111, which is the MAC address it will show up now. So that is how communication happens. MAC address locally, it works. When you want to communicate remotely, I modem network, IP network, MAC address. With respect to the IP address, though, it does not change. IP address, yes, source. IP address, yes, source. Destination, destination. No complications because IP addresses can be used to communicate remotely. Right, going to text thread, what happens when the actual destination is not on the same LAN and is remote? What happens is the destination MAC address becomes the MAC address of the default gateway. It's very important because for my questions, you definitely be tested on that knowledge. Kuziva kuti kana ndiri communicate remotely, the destination MAC address panobva information from the origin panapa inenge yakaiswa ichi default gateway. Haiswe device E because device E rook is in the remote network and MAC address, they don't have the capabilities to communicate remotely. What happens when the PC1 tries to reach the web server? Does this impact the network and the data link layers? Yes, the data link layers are impacted and I've already explained why. Right, rows of the network layer addresses. When the source and destination have a different network portion, this means they are on different networks. That's the definition of an IP address. The first example at Tapa, they were in the same network. Therefore, their prefixes were the same. That's the prefix. Where's the first example that we gave? Right, this one. Two addresses are PC1 server. They are in the same network. Why? Because of these prefixes being the same. 192.168.1. 192.168.1. They're the same. It means they're in the same network. Akangosiyana, for example, tikaita kangoisa 2 panapa. Ato 2 network akasiyana 1. Right? That is what is being demonstrated right here. So, chinotipa kuti tizive kuti this is the remote network. Kutosiyana kunoita maadresses why? Imwe na 192, imwe na 172. That's it. Those are two different networks. That is remote communication taking place. The role of the data link addresses different IP networks. Going through the text, when the final destination is remote, layer 3 will provide layer 2 with the local default gateway IP address, also known as the root address. So if the final destination is remote, the layer 3 provides the layer 2 with the gateway so that it uses that as the destination MAC address. The default gateway is the router interface address that is part of this line and will be the door or the gateway to all other remote networks. If I'm looking at this PC, what is the gate out of the network? This one. That is what we call the default gateway. Very important understanding the default gateway. All devices on the line must be told about this address or their traffic will be confined to the LAN only. Kana usina default gateway, it doesn't mean you can't communicate. If this device doesn't know this default gateway, it can still communicate with this one because they are on the same line. It can still communicate with this one because they are on the same line. They'll be communicating using the MAC address. But if you now want to communicate remotely, it will not be possible because you don't know the gate out of the network, the door out of the network. So the default gateway is very important. Even when we are doing configurations, you need to configure every device that you have in the network with the default gateway so that it is able to identify the door out of the network. If it cannot find the door out of the network, then it cannot communicate with the remote networks. Therefore, no communication basically. Once layer 2 on PC1 forwards to the default gateway, the router then can start the routing process of getting the information to the actual destination. Right. Role of the data link layer addresses continued. The data link addressing is local addressing, so it will have a source and destination for each link. The MAC addressing for the first segment, source A, destination 1. Okay. Communication yedu, takudotaura communication yese iri kuitika. Panobva information yedu iri kubva this PC iri kuenda kuserver. Right. What happens ichibva panapa? Ichibva panapa, comrade wakagara apa vachatypa something web page whatever it is vari kuapplication layer. Application layer information yodzika, we call that information data. Yopinda mutransport segment, yopinda munetwork IP address, IP addressing yobva yaitwa imomo rapacket. So ndo panoitwa this process yekuti what is the source yobva yaiswa, what is the destination yobva yaiswa. Tamlayer number 3 yodzika MAC addressing yakunzi frame, ndo panoiswa information ishi yekuti the destination the source ichi, right? Since destination yedu initially iri remote, MAC address has no capabilities to communicate on remote networks. Ndo paino send a message to the default gateway, it gets a response in a MAC address a default gateway. Ndo paino iswa panapa. Term layer number 2 destination MAC address yaiswa, source MAC address yaiswa. Information yedu yechinjwa kwa bits yobva yabuda pama PC yobva yatravela yakuenda to the medium yosvika panapa yoconvertwa yodzoka paframe, because this is a layer 2 device rinoprocessa maframes. Yoprocessa frame yoiuya panapa yakuphysical again because takupinda mune channel yobva yaenda mabits obva yaenda asvika panapa totanga waita de-encapsulation okwira. This is a layer 3 device inoprocessa svika palayer 3. So painosvika palayer 3 yobva yaona kuti the destination ndeye network ipi. But the most important thing chatoda demonstrate is what is happening at the layer 2. Layer 3 is very easy because layer 3, these addresses, they don't change per layer 3, right? Per layer 3, these two addresses, they don't change. Per layer 2, however, patinosvika panapa, right? Takuda kuya kunoko kuti tisende pane rimwe router iri. What happens panapa? The source inenge yainosh parikubva information yedu, right? The destination inenge ya MAC address yepanapa. Then packet redu parinosvika panapa, the source inenge yava yepano, the destination inenge yapanapa. Parinosvika apa, the source inenge yapa yepa default gateway, the destination inenge ya now ye the device iri apa. So the source mark and destination mark inochinja pese pairi kubuda ichipinda mune imwe network inenge ichichinja up until yasvika to the destination. I think, let me find a diagram which best explains that one. Let me see. Data link. Okay, we'll explain. First, router exit interface. Panap. Question say yes. You can raise your hand.
Can you please go back to the slide you were talking about?
This one.
Yeah, exactly that one. My question is, when these devices are changing the MAC addresses for the remote network, then when we get to the last router, this MAC address, that the original one that we started with,
the original one is this one.
Yeah.
Yes.
The destination one. Where is it coming from, and where was it stored all this time when this process was happening?
Oh, this one. This is the destination, right?
Yeah.
That's one. That is the one
Yes.
you're asking.
Yes, because from all the routers here, we don't see it, and on the last router, that's when it appears. Where was it stored, and where was it?
Okay, good question. Right. Yeah, it wasn't stored anyway. It was right there with this device all this while. Right. This is what happens. We have a process. After this, you can Google what is ARP. We have a process called ARP. Right. If we are communicating with the remote network, the main IP addresses, the main actor is the IP address, not the MAC. The main actor is the IP address. The IP address is responsible for remote communication. However, like I was saying, it's very important to know what is the physical location of the device. And the physical location of the device is defined by the MAC address. So, packet redu parinosvika panapa. I think kwesoko, let's suppose we've understood kuti kwesoko rabva sei. Packet redu rasvika panapa now. Because rine network ID, it is able kusvika panapa using my network IP addresses. However, parinosvika panapa, rinenge risiri kutomboziva kuti what is this destination IP. Rinenge risiri kuziva, it does not know. It sends a message to the network, a broadcast, every device in the network. Kuti, I have an IP address iyi rapa, because it knows. Parabva kuno kuku, kwekutanga kuno. Parabva pekutanga, panapa chai pekutanga, patafoma the first frame ne the first packet. This address iyi tandiri kutoiziva ichi. Ye destination, the IP tandiri kuiziva, yatinenge tisiri kuziva ndeye maki. So parinosvika panapa, it sends to the network a broadcast. I have this IP address. I want to know which device has an IP address like this. I want the MAC address of that device. So information paino send or broadcast, this device here, ndo rinoresponda ne MAC address. MAC address paino dzoka, that is the MAC address which will be used at this router here as the destination MAC address.
Okay.
Are you following?
Now it's clear.
It's clear,
Yeah,
right?
now it's clear.
Yeah, but
Yeah, because
unfortunately,
that's sorry for cutting you. That's
yeah,
where
no
I wanted to
problem.
ask. With
No
address
problem.
resolution protocol, inongoshanda on the same network, or also it works on it only works on the same network. So kapainoshika pa router right? It uses the app to
Yeah.
request the MAC address.
Yes.
All right, now that's clear. That's clear. Thank you so much.
All right. So now going a bit forward, it depends. All right. This is what is happening on the first router. So they're now simplifying first router radio in the lip. I think at this stage, let me remove this. Pan up. What is happening on the first router? The MAC address for the first segment is source is for the PC1, no problem. The destination is for the default gateway. We've explained that one. So default gateway, pan up. That becomes the destination MAC address for the frame rinosendwa kubva up kuenda parouter. Frame rinosendwa apa kusvika parouter number 1. The source ndere this device, the destination ndere default gateway. What happens kana takubva up kuenda parouter number 2? The source ndere first router exit interface. So source now yaye exit interface repanapa, destination yaye pap yaye panapa. That is what happens ku frame. So you can see kuti kana tiri kushandisa maframes, MAC addresses anenge ari kuchinja depending nema networks. Panga tiri munetwork inoyi, MAC address source ne destination MAC yanga iri AAA ne 111. Patinosvika panapa hatisi so rina AAA ne 111 iyi. Patinozosvika panapa tane mamwe a set of mamwe MAC addresses. MAC addresses, they are confined within a network. As we will go, you will realize kuti panapa same network rapa. Interface riri up and interface riri up. My IP address is why anenge akaiswa same network. And that is the reason why okay, we had the second one. Right. So I was saying, as we will go, necessarily you realize kuti same network rapa. Two my interface iri the interface iri pa second router, they are on the same network, and that is the reason why these two can communicate using my MAC address, because they are on the same network. They are not on different networks. Then report iri rapa interface iri ne device room, they are on the same network, and that is the reason why they can communicate using my MAC addresses. MAC address, same local area network, communication, yes. Remote, no. You need help of a layer 3 address. Right. Notice that the packet is not modified, but the frame is changed. We have touched on that. The packet remains the same. Can talk to a packet, we are talking of a layer 3 PDU. Therefore, the L3 layer 3 IP addressing does not change from segment to segment like the layer 2 MAC address. Layer 2 MAC changes from segment to segment. Layer 3 addressing remains the same since it is global and the ultimate destination is still the web server. And that closes this session, ladies and gentlemen. It wasn't 5 minutes as first advertised, but I hope concepts being pushed were well understood. Any questions before we close? Any? None? Thank you very much. 7 started, 4 are left. Thank you very much for attending this session. I think we're done. IP addressing
Checkpoint
done.
exam.
Yes, question?
Checkpoint exam, no return.
Checkpoint exam tomorrow.